This is 6.2, the law of cosines. You were introduced to this in geometry and in algebra 2. So this should be a pretty easy lesson. We'll just kind of go through it. Let me know if you're having some difficulties. You use the law of cosines to find side lengths and angle measures of a triangle. We also will review the adherence formula to find the area of a triangle. So on this slide, what you need to know, the law of cosines formula can be used if you're given a side, side, side triangle or a side angle side triangle. This is the law of cosines. There's multiple ways to write this formula. Sometimes they solve it for the angle measure. Sometimes they have an a squared on the left without the radical. Multiple ways to rewrite it. So go ahead and write down those pieces that I've highlighted on the smartboard in your notes. Okay. Example. How do we actually find a side length using this formula? You choose if you want to write this down or not, if you remember it or not. So what we're giving you in this triangle is a side angle side. We're giving you side C, side B, and angle A. And we want you to find the missing side length of A. So we just substitute everything in. So A equals, and notice the pattern, it's the two sides you don't have, or that you have, b squared and c squared. So 5 squared and 7 squared. So 5 squared plus 7 squared minus 2 times 5 times 7. And then cosine of angle A, which is 45 degrees. And then we have some simplifying to do. So 5 squared, 25. 7 squared is 49. And then negative 2 times 5 is negative 10. Negative 10 times 7 is negative 70. Cosine of 45 degrees. And then you want to, if you're comfortable, throw it all in the calculator in one shot, then square root it, depends on how comfortable you are. So 25 plus 49 minus 70 cosine of 45. And then square root it. So there's what side length A is. Okay, on that one. This example, we're not going to solve it, but I just want you to notice the difference. When you have different letters, not A, B's, and C's, can you still use the pattern of the formula to set it up? So this is your side P. Remember, it's always opposite the angle. This is side R, opposite this angle, and then side Q. And if we want to find out what is Q, you guys help me set up the equation. Q equals the square root of gonna go in that radical? P squared plus R squared minus 2PR cosine of what angle? The side we're working with, Q. And then you could substitute all the pieces in and find what length Q is. So be comfortable without just having them be A, B's, and C's. Alright, now we're going to go ahead and find an angle measure using the law of cosines. So we have this triangle given, and we want to find out what is angle R. So side R is 6, side P is 3, and side Q is 7. And what we have is a side, side, side triangle. So, to set up the equation, since we're working with angle R, we set up the equation as side R. So R equals P squared plus Q squared minus 2PQ cosine of R. And now we would substitute everything in and then continue undoing until we can find out what the cosine of R is with inverse trig. So side R is 6, side P is 3, side Q is 7, P and Q again, and then cosine of R. What might we want to do first to solve this equation? What might we want to do first? Pardon me? Pull out the 3 and the 7? Or simplify it? Simplify it, okay. So 3 times 3, 9. 7 times 7, 49. And then maybe multiply the negative 2, 3, and 7 together. Negative 42. Then what might want to do next? Add the two terms together. 9 and 49 is 58. And then you find out what to do next while I answer the door. Now what do we want to do? Solve, but how? What can we do with that radical? How do we undo a radical? Square it. So we might want to square this side and square this side. Is that true? So then we would have 36 on the left and just that radicand left on the right. Now what? Subtract the 58 from both sides, yes. So 36 minus 58 equals negative 42 cosine of R. So this will make it a negative 22, yeah? And then what? Go ahead, then divide by negative 42. So negative 22 divided by negative 42. Cosine of R equals, as a decimal, 0.523. And now how do you find the angle measure? Inverse trig of cosine. So angle R will equal the cosine inverse of 0.523. Make sure your calculator's in degree mode. 68.41 degrees. Now if we ask you to solve this triangle for the other pieces, I would then probably do the law of sines next, and then the triangle sum theorem to find that third angle. Law of cosines is longer than law of sines.